This video is going to show you some of the basics about E fields at a point in space. Alright, let's say you have a balloon and the balloon has a net positive charge on it. That balloon is going to exert something called an electric field. That electric field is going to radiate away from the balloon because we know electric field is the path a positive charge would take if it was brought near the balloon. Now, this electric field is actually a force field. Like in science fiction or real science, it's a force field, and it acts on anything else with a charge. So if your friend brings a balloon close to it that also has a positive charge, it'll interact with the electric field and it'll feel a force. And we know that force as Coulomb's force, or a force due to Coulomb's law. If your friend brings an oppositely charged balloon, it'll also interact with the E field. In this case, it'll be attracted to it, and the force it feels is due to Coulomb's law. If I take a negative charge, it's also going to have an electric field just like a positive charge. The path a positive particle would take, and the positive particle would come right towards the negative charge. So the real question here is, what is the E field at this point in space? Well, this point in space is through the E field itself, so there's the E field we had earlier. And I know from previous information that the force is equal to Q times E, and I'll start with the Q1. And I can rearrange that for E is equal to F over Q1. And I'm going to write that as the force times 1 over Q1. There's going to be a reason why I'm writing it weird like this. And that force, if I had a charge in that point in space, that force can be calculated from Coulomb's law. So the force is kq1 q2 over r squared. Now if I take my equation above that says F times the product of 1 over Q1, and I replace the force with Coulomb's law's equation, then this becomes E equals kq1 q2 over r squared times the quantity 1 over Q1. Now that you can see the reason, because my Q1s, they're going to divide out. So now the electric field at this point in space is kq2 over r squared. Well, we don't have a Q1 and a Q2 when we're finding out the E field. All we have is an empty spot in space and whatever our charged object is. So we're going to learn this as the electric field E is equal to kq over r squared. And E's units are going to be newtons per coulombs or volts per meter.